Hello, this is Lab 3, resting metabolic rate. So today we have a subject who we are going to place on the exam table and take about 20 to 30 minutes to measure his resting metabolic rate. Before we do that though, we're going to go through a full calibration of the metabolic cart and sort of talk about some of the differences between resting and exercise. Because during exercise, the subject is expiring very forcefully. That will force air through the metabolic cart. But during resting, because the breathing is going to be a lot less forceful, we do have to install a device in the back of the cart to sort of suck the air through, keep the air moving through. And when we calibrate the cart, there are going to be some differences as well. So I want to first point out that when we're doing a resting metabolic rate test, our metabolic carts have two different versions of the software. So we have an exercise version and a resting version. So we're going to open up the resting version. And the first thing that we're going to do is do the gas calibration. Okay? So the gas calibration is done every time we do a test to account for the differences in the environmental conditions. Now when we did pulmonary function testing, actually when we do pulmonary function testing in a couple labs, you'll see how we can hand calculate to make these corrections to adjust for the way that the environment changes on a daily basis. The metabolic cart will do that for us. So what we're going to do first is determine, based upon the barometric pressure, the humidity, and the temperature, what is the percentage of CO2 and oxygen that is in the air around us, because if we do not know that accurately, then we cannot measure how much the subject is expiring. Okay? So how we're going to do this is first select the gas calibration button. And we're going to put in the current environmental conditions in the room. We have this device here that measures these things for us. So I'm going to make these corrections based upon the current conditions. So it's 22 degrees Celsius. The barometric pressure is 747 millimeters of mercury. That will change a lot of times due to the amount of cloud cover that's overhead, etc. And then lastly, the relative humidity today is 66%, which is a huge difference from the last time we calibrated this cart when it was 17%. It has been raining a lot. It is currently May as we're making this video, so it is getting humid here in the city of Louisville. That still seems very high though, 66%. That might be the highest I've ever seen. Okay, so once we have the environmental conditions in, click OK. We're then going to turn on the calibration gas. So basically what we're going to do is compare the room air to the air that is in our calibration tank. We know the percentage of CO2 and oxygen in this tank. We're going to compare it to the room. So we're going to open this up. Click OK. The room air will now be sampled. It's going to take a few seconds. Prompting me now to turn off the calibration gas. So I'll do that. Click OK. Now what we see here is the percent change in O2 and CO2 concentration. That's a pretty big change. If we proceed with the test with a change that is this large, the accuracy will be a bit diminished. The reason why there is such a big change is largely because of the changes in the barometric pressure and the humidity that we found in the conditions today versus the last time that we calibrated the cart. So I'm going to save this, and unfortunately now I'm going to do the same process again. So again, bear with us as we run through another gas calibration. It's going to ask me to put the conditions in. They're obviously the same because we just put them in seconds ago. Okay, turn on the tank, and we'll run the gas calibration one more time. This time at the end of it, we should see a smaller than 1% change, which is what we want to see, and then we can proceed with the next part of our calibration. So while this is working, I'll go ahead and talk about the next part. The next thing we're going to do is calibrate what we call the flow meter. The flow meter is what moves the air through the metabolic cart and allows us to take measurements. We like to calibrate the flow meter to mimic the expiration that the subject will be doing during the test. Now, during a resting metabolic rate test, the subject's breathing should stay consistent and be at somewhat of a low level the entire test. Okay, so quickly, now we see a 0% change in oxygen, a 0.4% change in CO2. So I'm going to save it again. Now our gas calibration is complete, and we can move on to the flow meter calibration that we were just talking about. So when I click this button, we'll do the flow meter calibration. Again, it's going to ask me to put in the environmental conditions. They match what I put in earlier, so I can just click sample baseline when we're ready. Now what we have here is it's called a 3-liter calibration syringe. This is what we use to calibrate the flow meter. Human lung capacity is around 3 liters. That's why we use a 3-liter syringe. So what we're going to do in order to calibrate the flow meter is, again, try to mimic the breathing that the subject will do during the test. So I'm going to perform 5 very slow pumps that will simulate the breathing that our subject will be doing during the test. Now we'll contrast this during an exercise test, which we'll show you later in the semester. We'll be pumping it much faster, moving higher volumes of air, because that's what occurs during exercise. Okay, so this is for resting again, so I'm going to click sample to baseline. Make sure our dilution pump is turned off, which is here. So I'm going to first perform basically 5 flushes to get as much air out of the system as possible, and then our next 5 will be recorded as actual strokes. So I'm going to pull this handle all the way out. Now notice there's a blue line that is showing on the graph. When I'm doing my actual strokes, I cannot go above that blue line, so I'm going to kind of practice for that with these next couple, moving very, very slowly. It's almost agonizingly slow. So this is my last flush. I'm going to go very slow just to kind of practice the force that I need for the actual test itself. I'm not quite under the blue line, but I'm right touching it. All right, so these next 5 are going to count. And this is simulating the rate of flow that will be occurring during the test. Because our subject is resting, there will not be large volumes of air moving through the cart. Two more. All right, so we have a nice flat line. Our peak did not get above 50 liters, which is what we were looking for. So we're going to save this. So we're finished the carb calibration. Before we take a break and get our subject ready, I'm just going to show you quickly what we're going to do. In order to do this test, we'll have the subject lay supine on the exam table. Head will be resting on a pillow. Then we have this gas collection hood. So what we'll do is place the bubble, which is hard plastic, over top of our subject's head and upper thoracic cavity. We're going to then wrap the soft plastic drape around the back of the pillow, around the torso, and kind of flatten it on the stomach. Okay. We'll then hook up the hose to one end of the hood. That's for expired gases. Inspired gases are going to come in through one hole that we'll leave open. Okay. It's critical to make sure this is not covered. Once we get our subject in place, we're then going to turn back on this thing known as the dilution pump. That's going to create some of that suction to make sure we're pulling air into the bubble and then pulling it out of the bubble as he's expiring into the cart for analysis. Okay, so we'll kind of run through this setup of this gas collection hood momentarily. We're going to take a quick pause, get our subject in position. We'll be right back.